Hello everybody, welcome back to another video. In this video we're going to talk about free response question 2 from 2001. In this problem we're given a table of values like days and the corresponding temperatures to days. Alright, and also it says that W is a differentiable function, and also this temperature is being recorded every 3 days over 15-day period, as you can see. Alright, so let's get started. In part A, it says that they use data from the table to find the approximation. So basically we're going to approximate W prime 12. Right, we're going to try to approximate this rate of change in 12th day. So basically part A, W prime 12 is going to be equal to, so we're going to select any 2 days. For example, I'm going to select day 6 and day 9 and their corresponding temperatures, as you can see. Alright, so basically W9 minus W6, basically we're going to apply the rate of change, which is slope, divided by 9 minus 6. So the temperature, approximately, the temperature corresponding to day 9 is 24, and the temperature corresponding to day 6 is 28 over 3. So 24 minus 28 is equal to -4 divided by 3. That means the temperature over time is decreasing, dropping down at a rate of -4 over 3 centigrade or Celsius degree per day. Okay, that's the first answer. In part B, let's move on to part B. In part B it says, approximate the average temperature in degrees Celsius of the water over time this interval between 0 and 15 using trapezoidal sum with the subintervals of length delta t 3 days. So basically, first of all, in trapezoidal sum, we basically try to put trapezoids under the curve as many as we can. Okay, so we know how to find the area of a trapezoid. Let's say base 1 plus base 2 times height divided by 3. So basically we're going to apply the same thing. So I'm going to continue part B right here. So the average temperature is going to be equal to approximately, if I apply the trapezoidal approximation, so we get 3 times 20 plus 31 divided by 2. So basically I'm going to apply this for every 3-day period. Okay, so 3 times another one, 31 plus 28 over times 2. Okay, and plus 3 times 28 plus 24 divided by 2. Okay, and plus 3 times 24 plus 22 divided by 2, and plus the last one, 3 times 22 plus 21 actually divided by 2. So when we find them and add them up, we get approximately, so we're going to get the accumulation of the temperatures, but if I want to find the average temperature, I need to divide the sum by 15. So basically it's going to be equal to 376.5. So that's the sum of the temperature. So if I divide this answer by 15, I'm going to get approximately 25.1 Celsius degree. So that's the average temperature. Okay. Alright, so let's move on to part C. So in part C, it says that a student proposes the function P given by this model. Alright, so this another model representing the same situation. So basically we're going to find P prime 12. Since we see prime and we're given the actual model of the function, so basically first we need to figure out P prime t. So in order to figure out the P prime t, so we're going to take the first derivative of this function with respect to time. So let's do it. So that's going to be equal to, if I apply the product rule, we're going to get 10 times e to the power of negative t over 3 plus 10 times 10t times negative 1/3 times e to the power of negative t over 3. So that's the first derivative. So if I substitute 12 into this first derivative and make the necessary calculations, what we're going to get is negative 0.549 Celsius degrees per day. Okay. What does it mean? It means that the temperature is decreasing at the rate of 0.549 Celsius degree per day when t equals 12 days. That's what it means. Alright, let's move on to part D. So in part D, it says to use the function p defined in part C to find the average value. So if I want to find the average value, if you remember the formula, I'm just going to put it right here. If I want to find the average value of something on a specific interval a, comma, b, what we're going to do is, so 1 over b minus a times integral from a, b, and we're going to take the definite integral of this expression. So we're going to do exactly the same thing. So basically, from 0 to 15, average value is going to be equal to from 0 to 15, and right here I'm going to put 15 minus 0 times, what is my function? P of t. Okay. Again, since this is calculator allowed problem, if you put this expression into your calculator, you're going to end up with this result, 25.757 Celsius degree. That's the average value in Celsius degrees over this time interval. Alright guys, thank you so much for watching this video. If you like this video, please subscribe, share, and give me a thumbs up and make a comment for this video. Thanks so much.